Here's pre-calc. It's your lecture for 1.3.3. So you're learning about rotational velocity or angular motion, and so that is the change in angle over the change in time. There's another video up on the Google Classroom that does a demonstration of a wheel on a bike going around, and it talks about angular velocity or rotational velocity as opposed to linear velocity. So rotational velocity or angular velocity is like radians per second, or it could be revolutions per minute, which you've heard as RPM. So let's try a problem. Problem 1-30, a wheel is spinning 500 RPM. How many radians per second is this? Give the exact value, meaning don't give decimals from your calculator. And remember that one revolution is 2 pi radians, because we just learned that yesterday. So we've got 500 revolutions per minute. And this is dimensional analysis or unit multipliers. So we're just going to try to turn this into radians per second. So I need to go from revolutions to radians, and they just told me that one revolution is 2 pi radians. So I want the revolution on the bottom. One revolution is 2 pi radians. Okay, because this is a unit multiplier, because 2 pi radians is the same exact thing as one revolution. So we're going to cancel that out. And then I also want to be in seconds, because they asked me for radians per second. So I got radians per minute, so I want to put minute on top and seconds on bottom and use a unit multiplier. So I know that there's 60 seconds in 1 minute. So those are, it's kind of like multiplying by a giant 1, because 1 minute and 60 seconds are the same exact amount of time, so I can just multiply it. Okay, and then I'm just going to multiply across the top. 500 times 2 pi would be 1,000 pi. And those are radians. And then 1 times 60, well, that's 60. I can get rid of some zeros, and then I can reduce this to 50 pi over 3. Okay, so that's what they want for dimensional analysis. That was just kind of a warm-up. We're going to do a much more complicated problem. So we're going to do this next problem. Oh, it's tangled up. Okay. So this problem, let's get it closer. This problem says the laser that reads a DVD uses constant linear velocity. This means that the laser will read the DVD at the same rate no matter where on the DVD the information is stored. To maintain the constant velocity, the DVD player changes the rate that the DVD spins. When the information is stored in the outermost track, the DVD spins at a rate of 200 RPMs. If the innermost track is 2 centimeters from the center and the outermost track is 5.25 centimeters from the center, how many RPMs must the DVD spin at to maintain constant linear velocity when the laser is on the innermost track? Complete the parts below to help you answer the question. So that, when I read that, my brain almost exploded. So I'm thinking of this first problem where there was some people running around a track, and someone had the inside and someone had the outside, and you guys probably already talked about that. I'm thinking about that when I'm doing this, but I'm also understanding that this DVD player is going to probably slow down sometimes, or speed up depending on where the information, like if it's on the inside track or the outside track that it's trying to read. So it says, what does it mean to have constant linear velocity? So that would kind of be like the person on the track is running, they're both running, 8-minute miles, but the one on the inside is going to win. Well, it just means that like their linear velocity is going to be the same speed, not necessarily their angular velocity. Express your response in terms of distance and time. So this says the speed doesn't change. Like whatever rate, like in centimeters per second or whatever, that's going to stay the same. The ratio of distance and time is constant. Or for a set time interval, an object will travel a set distance. So that's just kind of like if you were going to run around a track. Letter B says, will the DVD spin faster when the laser's on the inside track or on the outside track? So since it has to maintain like a constant linear velocity, it's going to have to spin faster when it's reading information on the inside track. The DVD must go around more times on an inside track to cover the same distance as a point on the outside of the DVD. Okay, and then how far does a point on the outside track travel in one rotation? That is, how many centimeters per rotation are there? So I'm going to put this away because I think I drew it out on another piece of paper. Here it is. So I just kind of drew a picture of our situation. So remember it told us that the outside track has 200 revs per minute. The inside track, they're eventually going to ask us that. We know linear velocity is the change in distance over the change in time, like miles per hour or feet per second, or in this case centimeters per minute or second. They're asking us in 1-131 letter C, how far does a point on the outside track travel in one rotation? That is, how many centimeters per rotation are there? So how many, like if I start here and I go around this outside track, how many centimeters is that? Well, that's like a problem that we used to know when we were little kids, where you just find the circumference. So we can just go circumference is going to be, what isn't it? Isn't it 2 pi r? So that's how far something's going to have to travel for one rotation on the outside track. So it's going to be 2 times pi times 5.25, and those are centimeters. So 2 times 5.25 is, I think it's just 11. It's 11 pi. Oh wait, no, 2 times, it's not 11, it's, because it's 5.25, it's 10.5, right? 2 times 5.25 is 10.5. You can use your calculator if you want to. So that is the answer that they wanted for letter C. And then maybe I'll use a different color. Here's letter C. And then letter D says, what's the constant velocity in centimeters per minute of a point on the outside track of the DVD? What's the constant velocity